Okay, let's move on into talking about what the book calls conventional forms of energy, conventional alternatives. And the reason they use this term is because they're not fossil fuels. We've had these sources of energy for a long time, but they're not as environmentally, quote unquote, environmentally friendly as what are normally thought of as standard alternative energy. So the three big conventional alternatives are nuclear, biomass, and hydroelectric. So there are some important points to see in those. Unlike The Simpsons, where you've got that hourglass, you know, you guys have probably some of the hourglass shaped, that's a cooling tower. That has nothing to do with nuclear energy. And yet for some reason that's come to symbolize. If anything, this shape should be, because these are the reactors for nuclear energy are in these big square buildings. There's really no exhaust associated with nuclear power. But that's what, all you need, it just looks like a box, basically. So the basic idea here is that you know, the global economy is really mostly fueled by fossil fuels. But the big limitations to fossil fuels is that they do pollute. I mean, look at all of the steps that the coal industries had to take to make the exhaust less polluting. And ultimately, you know, you'll see that one of those molecules that comes out of burning fossil fuels is carbon dioxide, and that's driving the global climate change issue that we'll get into in more detail. So we're looking for ways that don't pollute the air, don't pollute the water, lessen the impact on climate change. So these conventional alternatives, now some of them still have problems, but we'll see that at least from an environmental perspective, some of them are preferable to what we have with fossil fuels. A lot of times when people do not take account for everything, in other words, so you pay for, when you pay your electric bill, you get charged by the kilowatt hour, and that can be translated into how much coal is burned. Okay, so you're actually paying for the coal. You have to pay Duke Energy. All of those, the SCR and the limestone and the electrostatic scrubbers, that all costs money. Duke's a private company. They're not paying for that out of their own pocket. They're charging you for that. So electricity costs go up to make the air cleaner. But there's no cost put to dumping all that stuff that's removed off a mountaintop and put into a creek bank and creates all this environmental degradation. That's considered a cost that's not accounted for. And that's referred to as an external cost. It's not included in the actual price that you pay for your kilowatt hour. And a lot of what's happening within environmental science is actually attaching a value to that. So, you know, if somebody's using pesticides and you get honeybees that start dying, well, you don't get the cost of those that loss of honeybees in the cost that you pay for your broccoli. But if that has a dramatic impact on how much pollination happens by the bees and causes the production of vegetables somewhere else to go down, that's an external cost. So if you actually incorporate that cost into the cost of doing business, then suddenly some of these things start getting a lot more expensive. So that's the difference between a market cost and an external cost. And people are really starting to take that into effect. I'm going to take 5 more minutes. I think we can do the review in 20 minutes. So I'm just going to keep going here just for a minute. Basically, what this graph shows you here, the pie chart on the left is the energy that's produced. So those sources tell you the total energy that's produced worldwide. by these different forms of energy. And on the right is which of those are actually used for generating electricity. So you can see that the size of that slice for coal's only 27% of the total energy produced by the world, and yet when it comes to generating electricity, it's 40%. So you can see the emphasis there on the shift between how much the world produces and how much of that is actually used for electricity production. Nuclear also goes up, as does hydropower. Only 2.3% of the world's energy production is hydro, but a larger fraction of that is used for making electricity. So that's kind of the take-home message from that chart right there. Okay, so this basically is just describing what conventional alternatives are. Tells you, that we're dealing with nuclear, hydroelectric, biomass, less environmental impact. The idea is that if you take the global economy that's mostly based upon fossil fuels, and we want to end up with solar and wind and tide, we're never going to get rid of fossil fuel until it runs out, because there's certain things you can't do without using fossil fuels. But that these conventional alternatives are sort of a bridge. They are going to help us get from your standard fossil fuels to those pure alternatives, and that and at least some people are looking at it that way. Other people want to say, let's go straight to solar. That's got some problems if you want to maintain your standard of living. So they're intermediates along a continuum of renewability. Minor but substantial fraction of the energy profile is due to these. Nuclear in particular in some places is pretty large. Let's see, I'll kind of go through that. All right, let's stop there. Let's get rid of this. All right, open your notes up.